Artificial intelligence is everywhere, from self-driving cars to chatbots and even in healthcare. But have you ever wondered how AI learns? In today's lesson, we'll explore how AI is trained to recognize patterns, why optimization is crucial for better accuracy, how reinforcement learning teaches AI from experience. If you're excited to dive into AI's learning process, stay with us until the end. Remember, members get exclusive AI deep dives, so subscribe and join the AI Prosperity Hub membership. Unlike humans, AI doesn't learn by intuition or memory. Instead, it relies on massive amounts of data. Let's take an example. Imagine you're training an AI model to recognize cats versus dogs in images. First, the AI looks at thousands of labeled photos of cats and dogs. Then it identifies common features: whiskers, fur color, ear shape. Over time, it starts making accurate predictions. But here's the catch. If the AI is trained poorly, it might think a wolf is a dog or mistake a cartoon cat for a real one. This is why training AI correctly is critical for accurate decision-making in real-world applications like medical diagnosis, finance, and self-driving cars. AI training is like teaching a child to recognize colors. It follows 5 key steps. Step 1, data collection. AI needs large, diverse data sets. A self-driving car, for example, must learn from millions of traffic images. Step 2, data cleaning. Messy data leads to bad predictions. AI engineers remove duplicates, incorrect labels, and unnecessary information before training. Step 3, choosing a model. Different AI tasks require different models. Neural networks are great for image recognition, but we might use a decision tree algorithm for fraud detection. Step 4, training the AI. Here, AI adjusts its settings with trial and error. Step 5, testing and refining. AI is tested to check accuracy. If it makes too many mistakes, engineers tweak the settings. Just like athletes train for years to improve performance, AI models go through thousands of iterations to get better over time. AI can learn in different ways, but the 2 most common methods are supervised learning. Imagine teaching a child math. You show them 2 + 2 = 4, and they memorize it. AI learns the same way using labeled data to make predictions. Example: facial recognition software is trained on labeled photos of people. Unsupervised learning. Here, AI finds patterns by itself without labels. Example: Netflix's recommendation system groups users based on similar interests, even without knowing specific preferences. Combining both learning methods, AI can continuously improve and adapt to new situations. AI doesn't stop learning after one attempt. It continuously optimizes itself. Here's how it works. Gradient descent. Imagine rolling a ball down a hill. AI adjusts its predictions step by step until it finds the best answer. Backpropagation. AI learns from its mistakes. If it gets a math problem wrong, it adjusts itself to improve future answers. In reinforcement learning, AI teaches itself by trial and error, like a video game player improving over time. Example: AI playing chess. At first, it loses every game. Over time, it learns which moves lead to victory. Eventually, it beats the world chess champions. This is how AI becomes smarter, by learning from past actions and refining decisions. Even after AI is trained, it can still run into problems. The 2 most common are overfitting and underfitting. What is overfitting? AI memorizes data too well and fails on new examples. Example: a model trained on only high-quality cat images may fail to recognize blurry cats. Solution: regularization techniques prevent AI from relying too much on memorized patterns. What is underfitting? AI doesn't learn enough patterns and performs poorly. Example: an AI trained with too little data may fail to recognize a cat. Solution: AI engineers use more training data and better models to prevent underfitting. Fixing overfitting and underfitting, cross-validation, testing AI on different data sets, regularization, preventing over-reliance on patterns, balanced training data, using diverse examples. Real-world example: AI models for medical diagnosis must balance precision and generalization. Overfitted AI might fail on new patient cases, while an underfitted AI might misdiagnose entirely. AI is powerful but is not perfect. Let's explore some real-world challenges AI faces. Challenge 1. AI bias. AI can inherit biases from training data. Example: if an AI is trained on biased hiring data, it may favor certain candidates unfairly. Solution: ethical AI guidelines and diverse datasets help reduce bias. Challenge 2. AI energy consumption. Training AI requires massive computing power, which impacts the environment. Example: a single AI model can consume as much electricity as 100 homes. Solution: companies are working on eco-friendly AI models to reduce energy use. Final thought: while AI continues to evolve, understanding its limitations is just as important as learning how it works. Join our community for exclusive AI deep dives. Congratulations! You've just learned how AI trains, optimizes, and improves itself to become smarter over time. One key takeaway from this lesson is that AI doesn't just stop learning after initial training. AI models are continuously optimized, updated, and fine-tuned to improve accuracy and adapt to new challenges. This ongoing process, from self-driving cars to medical diagnosis, ensures AI stays relevant and effective. But our AI journey doesn't stop here. In the next lesson, we will explore the ethics of AI bias, fairness, and accountability. Want to take your AI knowledge even further? By joining our membership program, you'll get early access to exclusive lessons, bonus materials and case studies, direct Quanda sessions to answer your AI questions. Subscribe now and unlock the next level of AI learning. Remember, the world of AI is constantly evolving. The more you learn today, the better prepared you'll be for the future. So stay curious, stay informed, and keep exploring the limitless potential of artificial intelligence. See you in Lesson 7.